In this video, we are going to look at graphing lines. You might also have heard this called graphing linear equations, or maybe graphing linear functions. All of those are basically the same thing. And you guys have already been doing that for a couple years, so hopefully this is just going to be a good refresher for you. So I have the equation of a linear right here, and this is one form. There are other forms this one can take. We call this one slope-intercept form, and this is the one we're going to focus on for graphing. So this m, the coefficient on the x, that's going to be your slope. And b over here, the constant, that's going to be your y-intercept. So pause, put this up at the top of your notes, and write down that m is slope and b is y-intercept. Okay, let's practice that in the context of an equation. So if I have y equals 3x minus 4, what's the slope going to be for this one? Well, the slope is the coefficient on the x. It's not the x itself. Be really careful with this. The slope is just the coefficient. It's the number in front of the x, but not the x. So we might say here m for slope equals 3. My slope in this case is going to be 3. And when we get ready to graph, these are actually easier if you think about as fractions, because if you remember, slope was rise over run. And so we're going to think about this as being 3 over 1. All right, how about the y-intercept? Well, the y-intercept was my constant, which was right here. All right, and be really careful with this sign. The y-intercept here, b, is equal to negative 4, not just 4. Because remember, the equation was y equals mx plus b. So I need to take into account that negative sign there, and my y-intercept will be negative 4. All right, if I want to find a point on this particular line, this is something we've already worked on, just the phrasing is a little bit different. Do you remember the ones we did that look like this? F of negative 2. So f of negative 2 is the same thing as asking what is the y value when the x value on my line is negative 2. And to find that, just like we did before, we're going to substitute in negative 2 for the x. And we're going to work this out. So 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10. So f of negative 2 is negative 10. That's what it would have looked like on the last test. This is exactly the same thing. It's just phrased a little bit different. All right, let's do the same thing with this one. Well, think about the way that linear equation looked at the beginning. Y equals mx plus b does not look like what I have here at all. So the first thing I'm going to need to do is I need to get y by itself. Okay, so let's see what we need to do here to get y by itself. I'll subtract x from both sides. All right, notice that negative 14 and negative x are not like terms. It really doesn't matter what order you put them in. Commutative property says it doesn't matter, but I want to make it match this. So I am going to choose to put negative x minus 14 because I want it to look like y equals mx plus b at the end. Okay, I still don't have y by itself. I need to divide both sides by negative 2. I'm going to divide each thing by negative 2 separately. Okay, so here's something that people have found confusing in the past. Look at this one. What do you think this is going to simplify to? Well, if you remember, there's an understood 1 right here in front of the x. So I have negative 1 over negative 2, and that will simplify to be positive 1/2. I understand that 2 divided by 1 is 2, but that's not what we have here. I have 1 divided by 2, so it's going to be positive 1/2, still with an x. And then right here, negative 14 divided by negative 2, positive 7. Okay, what was the variable that we used for slope? That's going to be m. So in this case, m equals 1/2. And the variable that we used for the y-intercept, that's going to be b. And in this case, b equals 7. Remember, the slope is the coefficient of the x, not the x itself, just the number in front. And the y-intercept is the constant, the one that doesn't have an x. Okay, so if I have an x value of 5 and I want to know the y value that goes with it, well, this is the same thing as asking for f of 5 because f of x and y are the same thing as long as y is a function. So I'm going to substitute in 5 for my x. All right, so we're going to get in the habit of working with these as fractions. I do not want to see any decimal answers on these. I want to see fractions because I want you guys to get accustomed to that. You're going to need that for your college courses. So 1/2 times 5, well, that's going to be 5 halves. And 5 halves plus 7, well, 7, if I get a common denominator, that's 14 halves. So 5 halves plus 14 halves is 19 halves. This is going to work out to be 19 halves. Okay, now let's look at putting that on a graph. So I have y equals negative 3x plus 2. Let's identify what we have. You guys tell me what is m and what is b. Well, m is going to be negative 3. It's the coefficient on x. And b is going to be 2. That's my y-intercept. So when I get ready to graph this, I will count the y-intercept first. So I'm going to come right here to 2 on the y-axis. Please make sure you put your y-intercept on the y-axis. I have people that get this mixed up all the time. I'm going to put 2 on the y-axis, and then from that point, I'm going to count the slope. Remember we said slope is rise over run, so it would be nice if I had a fraction there. I'm going to go down 3 because it's negative. So 1, 2, 3, and then to the right 1, because the 1 in the denominator is positive. If I go down 3 and left 1, it's like I did negative 3 over negative 1, which is not what I want. I want negative 3 over positive 1, and so I'll put a dot right here. And then I connect the dots. It's kind of hard to aim on my screen. Hopefully you guys are going to be able to do a little bit better with your paper and pencil, and feel free to use a ruler because this is a straight line. We want to be nice and neat, and it'll be easier to find things if it is accurate. Okay, so now I want to find negative 5. Okay, so there's several different ways I can do this. I can do this on my calculator. I can do this by hand. So I'm going to choose to do this one by hand. I'll put in negative 3 times negative 5 plus 2. Negative 3 times negative 5 is positive 17. I'm positive 15, sorry. And then 15 plus 2 is 17. My y value there is going to be 17. Okay, so look at the next one, x equals 0. Remember that when x equals 0, I always have the y-intercept? We already know what the y-intercept is. We have it right here. The y value is going to be 2. All right, how about positive 5? Let's substitute that in. Putting positive 5 in place of x, negative 3 times 5 is negative 15. Negative 15 plus 2 is negative 13. So those are the y values that are on this line. If this line were extended out from negative 15 to positive 20, say, we would be able to see this point of negative 5, 17 and this point of 5, negative 13. We're a little bit limited because the graph we have on our paper is only going out to 10. All right, let's try this one. So do you guys notice that this one is not in the right form? I need to get y by itself. So what will be the first step to get y by itself? I'm going to subtract 2x from both sides. Okay, I still don't have y by itself. I've got that negative in front of it. Remember that negative is the same thing as negative 1. There's that understood 1 there. So I'll divide each thing by a negative, and I get y equals 2x minus 4. Negative divided by negative is a positive, and positive divided by negative is a negative. Okay, so let's graph it. So you guys tell me, what is m? What is b? Well, m is 2. It's the coefficient on x, which is the same thing as 2 over 1, so I can work with that fraction. And then b is negative 4. Don't forget about the negative sign. Okay, so now let's put this one on here. First, I'm going to go to the y-intercept. So I'm going to put negative 4 on the y-axis. That's my first point right here. And then from there, I'll count my slope. Well, this time the 2 is positive. So from the y-intercept, I'm going to count up 2 and write 1. All right, and there is my next point. Okay, so take your ruler, connect the points. I will aim the best I can on my screen here. Make sure you put arrows on that because lines go on and on forever in both directions. The domain is negative infinity to positive infinity, so we want to make sure we illustrate that with our arrows. Okay, so now if we find these particular function values, all right, well look, here's -4, and if my line is graphed correctly, I should end up with the same point that I'm going to get algebraically, and the same thing right here for 4. So if I substitute in -4, 2 times -4 is -8, minus 4 is -12. So -4, I ought to be down here at -12. You can see my line is not as accurate as it should be. All right, how about when x equals 0? What does that find for us? Remember, that always finds the y-intercept, which is right here. And then let's put in +4. 2 times +4 minus 4. 2 times 4 is 8, minus 4 is 4. So the 0.44, I was pretty close on that one. 44 should be on my graph right there. So if you guys drew it with your ruler, you probably got a lot more accurate than I did. All right, let's try this one. Uh-oh, we have the same problem. We don't have y by itself. Okay, let's see what you guys can do to get y by itself. Okay, so how did you do? I got y equals positive 2x plus 2. I'm sorry, positive 2/5 x plus 2. So my slope is 2/5. That one's already a fraction. I don't need to change it. And my y-intercept is 2. All right, so I'm going to go to 2 on my y-axis and put a dot. And then from there, I'll count my slope. So I want to go up 2 and over 1, 2, 3, 4, 5 places to the right. And then I will connect my dots. Sorry, I've got a little bit of a smear there on the y-intercept instead of a dot. But that is what my graph is going to look like. All right, let's find the points on this one with our calculator. So I went ahead and put 2/5 x plus 2 into my y equals screen, and I'm going to graph it. All right, now the value that it asks us to find is -6. Do you remember what we typed to find a value? Second trace, and then I'm just going to hit enter on value. And the value I want my calculator to find for me is -6. And hit enter. And it tells me the y value on that one is -0.4. You can see it just barely under the axis right there. And it'll be fine to use a decimal on this one because that's what the calculator gives you. So everybody write in your box -0.4. Okay, now when I look at the one for 0, remember, I don't need to type that in my calculator because I already have it. I have 2. So I'm going to put -0.4 in this box and 2 in this box because when x equals 0, I have the y-intercept. All right, now let's do +6. So second trace to get to the calculate screen, hit enter. And this time I'm going to tell the calculator +6. And you see the value it gives me right here for y, 4.4. All right, so let's write that in our box over here, +4.4. And it's okay to use your calculator on these also. Okay, let's look at the same thing. I want you guys to see if you can get y by itself. All right, to save time there, I just went ahead and divided by -3 all the way across without writing it out. Okay, let's graph this one. So I'm going to go to -3 on the y-axis. 1, 2, 3. There it is right there. And then from that, I'm going to count the slope. And I'm going to go up 1 and to the right 3. All right, and then we will connect the dots. Okay, let's substitute in our values using the calculator again like we did before. Okay, I've already got this one in the calculator for us. So second trace, we want to hit value, and the one we want to do is -3. So you can see that one is going to equal -4. So -3, -4, if I were very good at graphing, would be on my point. But because I'm drawing it by hand, it's not